Here we look at an operation called a logical test, which is going to compare two numbers to each other, or we can compare two vectors or two matrices to each other, and compare such things as, is one greater than the other, is one less than another, are they equal to each other, and we can string these all together. The first part we'll talk about is the comparison test. I'll start just talking about scalars for right now. So I'm going to just assign a value of 6 to x. And I'm going to run this. And what I can do now is I can compare it to other values using these 6 commands here. So the first thing we can do is test, is 6 equal to, or is x equal to 6? Now what these logical tests are going to do is if the comparison is true, it's going to return a 1, and if it's false, it's going to return a 0. So in this case, I'm going to ignore the suppression. Just get rid of this for now. So what we expect is, because I'm assigning the value of 6 to x, when I then do the comparison here, it should return 1 for that being true. And indeed it does. One thing to note here is that for the comparison, I'm using a double equal sign in line 15, and in line 13, where I'm assigning a value, I'm using a single equal sign. So again, double equal sign for a comparison, a single equal sign for assigning a value. All right, so the double equal sign again tests, is the left and the right hand side equal to each other? Now I have the option of greater than or less than also. For example, so if I'm testing, is x greater than 6? Well, we should expect that to be false, since 6 is not greater than 6, and it returns a 0. If I say, is x greater than or equal to 6, which is going to be this compounded greater than and equal to sign, and if I run this, it gives me true. Is x less than 6? False. Is it less than or equal to 6? Is true. And then finally, we can have this tilde equals, which stands for not equals to. So in line 15 with this test, I'm saying, is x not equal to 6, or is 6 not equal to 6? And that's false, because indeed 6 is equal to 6. But if I change the right hand side to 8, I'm asking, is 6 equal to 8? Or is 6 not equal to 8? And it's true that 6 is not equal to 8. So oftentimes when we use these logical tests, we're going to be operating just on scalars, like we are here. We're comparing the left-hand side as a scalar and the right-hand side as a scalar. But we can also use these to compare vectors to scalars, vectors to vectors, matrices to matrices, and matrices to scalars as well. So if I say that x is now going to be, I'll just choose random numbers for right now. So the vector 1, 5, 9, 4, 2, 3, 5, 7. Assign that value. I can see, is x greater than, for example, the number 3. Now because the left hand side is a vector and the right is a scalar, it's going to interpret this to mean test every entry in x and see if it's greater than 3. So actually the output here is going to be a true or a false for each element in x. So we see here that when we're testing x versus 3, it's giving me 0, 1, 1, etc. So it says that the first entry is not greater than 3, the second, third, and fourth are, the fifth and sixth are not greater than 3, and then the seventh and the eighth are greater than 3. I can compare it with the equals to. So again, we have zeros everywhere except for the one spot where x, the entry in x is equal to 3. If I change this a little bit, let me get rid of this for right now. Let's say that I want x to be a matrix instead. Right, so it's now a 2-row by 4-column matrix, but I can do similar things now. I can say, where is x greater than or equal to 4? And now as a matrix, it puts in just those cells that are greater than or equal to 4. So the 5, the 9, and the 4, and then the 5 and the 7 in the second row. So in that way we can compare vectors to a scalar or matrices to a scalar, but we can also compare a vector to another vector. Right, so I'm going to assign x is 1, 5, 9, 4, And again, choosing random numbers here, I'm going to make a vector y that is also 4 entries. Now when we're comparing a vector to a vector, we have to make sure that they are of the same size. The exception was, like in the previous part, I compared a vector to a scalar, is the only time where the sizes don't have to match each other. So in this case, I can use x greater than y, and we're going to get 4 entries here, and we see that it's all the entries where the x entry was greater than the y entry. So in this case, it compared 1 to 9, which was false. 5 is greater than 4, 9 is greater than 2, 4 is greater than 0. And we can use all those same tests that we were just looking at. Where are they equal to each other? Nowhere. It's false at all 4 entries. Where are they unequal to each other? And that would be everywhere because they are different at all entries. And another piece of the logical tests, other than these comparatives, I'll call them, are they equal, greater than, less than or equal to, things like that, is we can, I'll get rid of these for now, we can use AND gates and OR gates. And we see how those are going to work here. So these take 2 elements, and we see we can make this truth table where we can see, are they both true? Is one true, one false? Are they both false? And we're going to see what the results are. So if I say x is true, or a 1, and y is false, or a 0, we can see, so I'm assigning 1 to x, 0 to y, we can see how this works. So first I'm going to test x and y, so that's just the ampersand here. So what this is doing is the AND gate is going to see, are both the thing to the left of the and the thing to the right of the and true. And it will only give us a true statement, or it will only give us true if they're both true. So let's see how this runs. So in this case, x is true, y is false. So the AND gave us a false, because they were not both true. But if I go up here and change this, if I make y true, x and y is a true statement, it gives me a 1. In contrast, let me put this back to 0. Instead of using x and y, again, which is false because they're not both true, I can do x or y, which is the absolute value sign. Now, the OR gate is going to look at what's to the left of it and to the right of it. If they are both false, it will return a false value. If one or both are true, it returns a true value. So let me run this. I get true because the x is true and the y is false. Or x is 1, y is 0. If they're both true, the OR gate will also give us a true statement. So the AND gate, again, is only true if both the thing to the left and the right are true. And an OR gate will be if either are true or if both are true. And also with the and OR gates, actually any number that's not 0, MATLAB treats as being true. So if I do 1 or 7, that means that x is true because it's not 0, y is true because it's not 0. So in this case, it returns a true statement. So the inputs, really it just cares, is it 0 or not 0, but the output of an or of an and will always be a 0 or a 1. Now we can string multiple of these together. Let's make z equal to 4, and I'll change the value of x to 3. So I'm going to work here only in with scalars for the moment, but this will also, if we want to use vectors or matrices, be applicable. So what I want to test here is it true, that x is less than y? We should expect that to be true, and it is. But what we might want to test is actually 2 things. Is it true that x is less than y? And is it also true that y is greater than z? And so if we evaluate with these parentheses here, we see the left side, is x less than y? Is 3 less than 7? Well, that's true. That part gives us a 1. Is y greater than z? Is 7 greater than 4? Also gives us a 1. So we can see if we break this down, we have a 1 to the left of the ampersand, a 1 to the right. So if I run this entire thing, since both sides are true, this is going to give me a true statement. If I switch this though, if I put my right side as y less than z, and if I run that, we expect that to be false. So now if I run all of line 17, it turns out false. And we can also string multiple of these pieces together. Again, using parentheses is probably going to help us out. So I want to know, are both of those things true? Or is this one thing true? So is x not equal to y? Right, so now if we look, we have this kind of compound thing happening. Inside this parentheses, I'm going to evaluate to a 0, like I was before. On the right side of the absolute value, I'm evaluating a 1. And if I run this entire line 17 now, to the left of the absolute value I have a 0, to the right of the absolute value I have a 1. So I should expect that 0 or 1 returns true because at least one of them was true.